Resistors primarily serve to resist the flow of electric current in a circuit. Resistors of two different value types are specified for this project, 10 kilo-ohm and 220 ohm. Because there are some different types of resistors from different manufacturers, I just want to show a couple different examples of what common resistors look like. Shown here are two examples each of 10 kilo-ohm resistors to the left and 220 ohm resistors to the right. And there are visible differences. We can see resistors here with a bluish body color or a brown beige body color. But the body color really makes no difference. And then we see some of these resistors have 4 stripes on them and others have 5 stripes. Now that part is a little more interesting. Anyone who has worked with resistors knows that most resistors are color-coded to indicate their resistance and their tolerance. And it is the colored stripes that make the difference. These colored bands are found on the body of the resistors and follow a standardized color code scheme. This chart titled Resistor Color Code is a reference for this color code scheme to determine resistance values and tolerance. So you can see we have colors that represent different digits that are used to identify the resistance, and that is used in combination with the colors here that give a multiplier to identify the resistance. Then we have colors that define the tolerance of the resistor. To determine which band represents the tolerance and which bands represent the resistance value, you should see a noticeable gap separating the band at one end of the resistor body. This band separated from the others represents the tolerance. The other bands grouped together represent the resistance. If you position the resistor with the band for the tolerance to the right and these bands for resistance to the left, then you can read this color code from left to right. So let's do that. Beginning at the left with this first band for the resistance value, the band is brown, and the first few of these bands are for the digits. So we look at the chart for the resistance color code, and we see the digit for brown is 1. Then we look to the next band. That is black, and we are still looking at the chart for digits, and black is 0, so the second digit is 0. Now we get to the last color band in this grouping for resistance. The last band of this group, before the gap, will be for a multiplier. It is orange, so the multiplier is 1000. We have read all the bands for the resistance value, so let's put that information together. The digits 1, then 0, give us the number 10, and the multiplier is 1000. So 10 times 1000 is 10,000 ohms, or call it 10 kilo-ohms. That brings us to the last band over here on the other side of the gap. This color band indicates the resistor's tolerance. So we will look at our resistor color code and the chart for tolerance. We see here that gold represents 5%. So we can say this resistor has a 5% tolerance. So this tolerance is a rating for the allowed deviation from the specified target resistance value. For example, a 10 kilo-ohm resistor with 5% tolerance is not hard to calculate. It could be plus or minus 500 ohms. This resistor could range from 9,500 to 10,500 ohms. And that's all good to know, but why is it some 10 kilo-ohm resistors look different than other 10 kilo-ohm resistors? Well, depending on what type of resistor you have, it could be marked with a different number of bands. and that will change some of the colors you see for a specific resistance value. This diagram shows two examples of a 10 kilo-ohm resistor. One of them has 4 colored bands, and the other has 5 colored bands. The color code scheme is not that different, even though there is a different number of colored bands. The overall number of bands on the resistor body determines how many bands will represent digits, and then there will be a band for a multiplier and a band for tolerance. It is normal for resistors to have color schemes with 4 bands or 5 colored bands. So to clarify, if there are 4 bands, then 2 bands are for digits. The third band is a multiplier. Then on the other side of the gap, the fourth band is for tolerance. If a resistor has 5 colored bands, 3 bands are for digits. The fourth band is the multiplier. And the fifth band on the other side of the gap is the tolerance. Another difference between the two resistors shown here is the tolerance. The one on the left is 5% tolerance, and the one on the right is 1% tolerance. For the project we're working on, the tolerance is not that important. When selecting resistors for this project, you can use this picture as a reference to identify 10 kilo-ohm resistors. And here is a picture with a couple of examples of 220 ohm resistors, one with 4 bands, one with 5 bands. When selecting resistors for this project, you can use this picture as a reference to identify the 220 ohm resistors. I certainly hope this review of color codes with 4 and 5 bands is helpful, but I know the resistors are small and the colors can be hard to see. Sometimes it's hard to see the gap separating the tolerance band as well. It's always a good idea to check the resistor with an ohm meter to make sure you have the right resistance.